Okay, this is a confidence interval for the mean with known standard deviation. Okay, so you got the formulas here for known standard deviation. We got percent confidence interval, x bar plus x plus minus z critical, and s over n. Okay, so if you remember the proportion, what you did last week was that this one was p hat, and then this one right here used to be the square root of pq over n. That was last week. Now, so that's the difference right here. So now we got the average, which is that one, the mean, and then we got the standard error. Okay, it's this one, s divided by the square root of n. So s divided by square root of n, again the same. The margin of error is going to be the critical z, and we got the critical z values here, times the s divided by the square root of n. Okay, so let's solve the first problem. We are given right here the mean, okay, of the current gas prices. It's x bar, and the standard deviation, see, it's given, it's 0.25, and we are being asked to construct a 90% confidence interval with a sample size of 40. So that's our n. Okay, as in last week, you always want to start with the assumptions and conditions. Assumptions and conditions. Okay, so again, there are three conditions which came from the Bernoulli trials, and let's start with the randomness. Okay, the 40 sampled and then the constant probability, or the less than 10% condition. Okay, and then we get to number 4. Before, when we had the proportion, we have the success failure condition, but in this case there is no p, so we cannot have a success failure condition. And so for this case, for the means, for means we are going to be relying on the sample size. Okay, sample size. So we look at the sample size. If it's 40 or near 40 or greater than 40, that's large enough. So we say that's large enough. Okay, the just say that in the concluding A and C statement. Okay, so we are going to say here, with conditions met, there's no comma there, sorry, we assume normal model and perform. What are we going to perform? Perform one sample z interval, because we are going to be using z. Okay, so remember this. You are going to say we assume normal model, so that's the first one, and then we are going to perform one sample z interval. Okay, we go to the mechanics now. Again, let's write. So this is 90% 90% confidence interval, and then so the formula is given right here. So it's going to be x bar plus minus z crit times s divided by the square root of n. So we just plug in values. Okay, so x bar is given as 3 plus minus, okay, this is 90%, and so we just look at 90%, it's 1.645, so times 1.645, and then the standard deviation s is given also, it's right here, 0.25, and then the n, our n is 40 divided by square root of 40. Okay, so we just compute the okay, let's start with the lower limit. So we use calculator. Okay, we calculate. Okay, and so what we have, we got 3. Okay, we start with minus, let's go to the left side, minus 1.645 times the standard deviation is 0.25, so 0.25, and then divided by the square root of, so we go square root of the sample size, which is 40. Oops, go get that, 40. Okay, hit enter, so it's 2.935, and then so we want to get also, this is the left side, so we're gonna go get the right side, and for the right side we just change this to plus. Okay, hit enter, and then let's just change that to plus. Oops. Okay, we backspace and then we add plus. Okay, and then we hit enter. Okay, so it's from 2.935 to 3.065. Let's just go 2.93 up to 3.07. Okay, let's do that. Write that here. We got 2.93 up to 3.07. Okay, there you go. And so that's the mechanics, remember? Okay, and so we just need to write the conclusion now. So for the conclusion, we are going to say we are, what is that? To do 90%. We are 90% confident that the true mean of gas prices is between 2.93 to units, the $2.93 up to $3.07. That's it. Yay!